Hello, so right now we're going to go through triangle similarities. This is from Geometry Semester 1, somewhere in Unit 4. So the first question you're going to see is, are these triangles similar? It's very easy to tell. All you have to do is make sure that you have three uh, congruent angles. So in this case, these are going to be congruent because as you'll see, this angle here, this 90-degree angle is the same as this 90-degree angle, so they're both 90. You have this 57-degree angle is going to be the same as this 57-degree angle. And because we know that all angles of a triangle add up to 180 degrees, we know that these third angles have to be the same. Because to figure out this third angle, it's just going to be 180 minus 90 minus 57. That's that third angle. And then 180 minus 57 minus 180 minus 90 minus 57 is again going to be that third angle. Um, so just that easy. In this case, you're technically showing that all three angles are congruent because of that theorem that the angles add up to 180 degrees. We know that we only really need two angles that are congruent. What happens if you're not given the same angles here? So I have one angle here that's 90, one angle here that's 57. On this triangle I have an angle that's 90, an angle that's 33 degrees. They don't quite look the same, so I'm not sure if these are similar yet. So the way to tell is just by figuring out what is that third angle here. If I figure out what that third angle is and it's 33 degrees, then these two triangles are similar. So I do the same thing I did before. 180 minus 90 minus 57 is 33. So that's what that third angle is. So this angle here is 33 degrees, which means I have at least two angles that are the same. I have the 90-degree angles, and I have the 33-degree angles. So yes, these triangles are also similar. This is really the problem that most people have the hardest time with. I do this a little bit differently. What I do is I'm going to set up the triangle similarities to show what I have here. And that's going to lay out the rest of the problem for me. Once I get the triangle similarities, I actually don't even need the triangles anymore. So let's start off. The first thing that you got to do is you got to recognize how many triangles you have here. When you first look at this, a lot of people look at this and say, okay, I have two triangles, but don't forget, I actually have this third triangle, this big triangle, triangle ABC, is one triangle. I have a second triangle, BDC, and I have a third triangle, BAD. So what I'm going to do is I'm going to go ahead and list those out. I'm going to draw those three triangles separated out, and from there I can figure out what a triangle similarity is going to be. So to do that, I'm just going to write out the first triangle that I have here, triangle ABC. ABC. Now, what I need to do is remember, for triangles, you got to make sure that when you're doing triangle similarities, you got to make sure that the order of the letters is the same. So here I have triangle ABC, and I'm going to start off by looking at triangle ADB. So the way to figure out what order these angles are going to be in is just to look at your diagram and look for the angles that are the same. So if I look at triangle in the big diagram here, I have triangle ABC. Okay, there's the big triangle there. And I'm trying to look at this triangle here, this ABD triangle. Okay, the first thing you can look at is angle A is going to be the same for both of them. That's the same angle A. Whatever this measure is, let's say this measure here is 20 degrees, that would be the same regardless of if we're talking about triangle ABC or triangle ABD. So I know that A is going to be the same. So since the big triangle, the one I started off writing, was A, the first letter was A, I'm going to start it off with the first letter A. The second letter that I used in the big triangle is B, and on the big triangle, B is the 90-degree angle. So what I need to do is I need to look at the smaller triangle, this ABD, and I'm going to see where is that right angle. And the right angle is right here at D. So since the right angle for the big triangle was the middle letter, was B, for the littler triangle, this ABD, I'm going to use D in the middle. That's going to be, so the 90-degree angle is right in the middle. Do the same thing with B, okay? So remember, since when we were talking about triangle similarities a minute ago, we said you really only need two angles. So here, C is just the angle that's left that we haven't checked. B is the angle that's left, that's the one we haven't checked. So those have to be last. Okay, now just for completeness, I'm going to go ahead and do the same thing with triangle BDC. Okay, so again, I look at which angle is the same for both triangles, and I'm going to stick to this first triangle that I wrote out, triangle ABC. I'm going to ignore the one that I just wrote. I'm going to see what the similarity is with this other smaller triangle. So I have angle A on the big triangle. That angle is not associated with this this smaller triangle here at all. The one that's similar between the two triangles is angle C. In ABC here, that's the last one. So when I'm doing the smaller triangle, I'm going to put the C last. Once again, the middle term is the 90-degree angle, ABC. That middle term is the 90-degree angle there. So I'm going to take, when I'm doing this smaller triangle here, I'm going to figure out which one is the right angle, and that'll go in the middle. And here, the right angle is angle D, so I put that in the middle. Then again, B is the one that's left over, A is the one that's left over, it's the ones that I didn't use yet, so I'm going to go ahead and just put those as the first letter. So, that was a lot of explanation for something that you may be sitting here thinking, okay, what does that really have to do with the problem we just were talking about? Let's take a look at that, okay? So what I'm going to do is I'm going to look at this ABC, ADB, BDC. I'm going to move that move that up so that it's out of the way here, and I'm going to bring back that triangle. So I'm sorry that D was in there a little early, but so I have my triangles here. So what I'm going to do is, with this similarity, I'm going to go ahead and set up my similarity ratios. Okay, and I'm going to do this. I'm going to start off again with a big triangle, and I'm going to look at the sides that I have. Okay, so I have two sides. One of them is a variable, but I have it. So the first side that I have here is AB. That's the side length is M, but I have that one for the big triangle. I also have this hypotenuse for the big triangle, which is AC. So I'm going to set up that ratio, AB to AC. Okay, so AB is the first two letters, AC is the first and last. I'm going to ignore the diagram now. All I'm going to do is write out the other ratios. So again, first two letters are on top, A and B are on top, A and C are on bottom. So that was the first and second goes on top. So for the second triangle, first and second goes on top, AD. Here I had first and last goes on bottom, first and last, AB. Again, just for completeness, I'm going to do the same thing here. B and D, first two letters, just like here. AB, first two. BD goes on top. On bottom, I have the first and last, AC. On bottom, first and last, BC. Okay, so let's actually start plugging all this in. If I plug all this in, I have AB, I know is M. I have AC, which is 11 plus 7, which is 18. For the second ratio here, I have AD on top, AD is 7. I have AB on bottom, AB is M. And then for this third triangle, I have BD. BD, well, they don't give me anything to plug in there, so I'll leave it as BD. I don't have BC, I don't have anything to plug in there, so that fraction, that last fraction there, doesn't matter. We're not going to use it at all. So at this point, this is the ratio that we have. All we have to do is solve, cross multiply and divide. So m times m is m squared, 18 times 7 is 126. Oops, I can't cross multiply and divide because this is a square, so all you have to do is take the square root. So then you figure out, depending on the problem, it may say simplify, you just simplify it. It may say give a decimal approximation, so you plug it into a calculator. And it's just that easy. That's how you figure out these problems. So again, write out the big triangle. In this case, it was triangle ABC, and then figure out the similarities for the other two triangles by comparing the angles that you have. And then from there, you can set up ratios pretty easily.